Hello, I am Dr. Imran Khan. Today we are going to discuss how do quantum computers work and the rise of quantum machines. Quantum computers perform calculations based on the probability of an object's state before it is measured, instead of just ones or zeros, which means they have the potential to process exponentially more data compared to classical computers. Classical computers carry out logical operations using the definite positions of physical states. These are usually binary states, meaning its operations are based on only two positions: a single state, such as on or off, up or down, 1 or 0, is called a bit. In quantum computing, operations instead use the quantum state of an object to produce what's known as qubit. These states are undefined properties of an object before they have been detected, such as the spin of an electron or polarization of a photon. So now we will discuss the rise of quantum machines. Quantum computing is the use of quantum mechanical phenomena such as superposition and entanglement to perform computation. Computers that perform quantum computations are known as quantum computers. Quantum computers are believed to be able to solve certain computation problems such as integer factorization faster than the classical computers. The study of quantum computing is subfield of quantum information science. So let's define quantum machine. A quantum machine is a human-made device whose collective motion follows the law of quantum mechanics. The idea that macroscopic objects may follow the laws of quantum mechanics date back to the advent of quantum machines in early 20th century. So here you can see some pictures of the chips based on the quantum computers, quantum machines. What is quantum computer? A quantum computer is basically a machine that can perform calculations based on the laws of quantum mechanics, which is the behavior of particles at subatomic level. Introduction to quantum mechanics. Quantum mechanics is a fundamental branch of theoretical physics which with wide applications in experimental physics that replaces classical mechanics and classical electromagnetism at atomic and subatomic levels. So our quantum computers are based on the quantum mechanics. So before going to the topic of quantum computing, we must understand the quantum physics and the quantum mechanics. Quantum mechanics is more fundamental theory than Newtonian mechanics and classical electromagnetism. So quantum mechanics can provide accurate and precise descriptions of many phenomena that these classical theories simply cannot explain at atomic or subatomic level. So here you can see the trend between uh, from year 1900 to 2025. So here the technology which we developed. Today all consumer processors are made out of silicon. So silicon is the second most abundant material on Earth's crust after oxygen. But silicon is not perfect conductor and it limits the mobility of electron. It carries a impose on hard limit on how densely you can pack silicon transistors. Not only does power consumption comes a huge issue, but an effect called quantum tunneling can also cause problem for keeping electron contained beyond a certain thickness threshold. So outside of research facilities, silicon transistors uh, don't currently get smaller than 10 nanometers. So, so that's why the Moore's law is in danger. So probably we are going to hit quantum level between year 2020 and 2030. So here you can see so the technology between year 1900 to 1940s. So here you can see the technology was based on electromechanical uh, components. And in 1940s, so they developed this solid state relay. And between year 1945 to year 1960, so there was vacuum tubes. So after the vacuum tubes, after the 1960s, so they start using the transistors in chips. So in 1970s, they developed these microprocessors based on the integrated circuit. So this was integrated circuit technology after the year 1970s. So also Intel introduced its first microprocessor in 1971. So it was Intel 4004 microprocessor. So here you can see that. So after year probably 2025 probably, so they will have either optical, quantum, DNA computations. So so we are going to use these quantum computing machines in next probably in next 1 decade. So this quantum computing and quantum computers is an important topic of discussion in today's research. So why bother with quantum computation? So computer technology is making devices smaller and smaller. So here you can see the first computers, and they are continually scaling down the transistors. And here you can see the chips are getting smaller. Then even here you can see it's the quantum computing. So uh, so the computer technology is shrinking and making the devices smaller and smaller. So reaching a point where classical physics is no longer a suitable model for the laws of physics. So that's why we need quantum computing. So physics and computation. Information is stored in a physical medium and manipulated by physical processes. The laws of physics dictate the capabilities of any information processing device. Designs of classical computers are based on classical framework of physics. So the classical physics has many problems, and it may be wrong or incomplete, and it is required to be replaced by the more powerful framework known as quantum mechanics. So here we will discuss about the quantum computing. So the all computing system rely on fundamental ability to store and manipulate information. Current computers manipulate individual bits which store information as binary ones and zeros. Quantum computers are are using quantum mechanical phenomena to manipulate the information. To do this, they basically focusing on quantum bits or known as qubits. So here we will discuss these qubits. So a bit of data represented by a single atom, that is one or two states, that is in one or two states, denoted by either this 0 or 1. A single bit of this form is known as qubit. A physical implementation of qubit could use two energy levels of an atom: an excited state representing 1 and ground state representing 0. So here you can see the nucleus. So here this is ground state and the excited state. So if this is in state 0, then it means that it is in the this ground state. So if we represent this state by this symbol 1, then it means that the atom is in excited state. So here this is the way of representing these states in quantum computing. So the important things like the superposition, qubits can represent numerous possible combinations of ones and zeros at the same time. This ability to simultaneously be in multiple states is called superposition. To put qubits into superposition, researchers manipulate them using precision lasers or microwave beams. So here you can see the superposition. So here you can see the different states, and here this is superposition. So here you can see in the figure. What is entanglement? So researchers can generate pairs of qubits that are entangled. So entangled like this. So here you can see, which means that the two of numbers of pair exist in a single quantum state. Changing the state of one of qubit will instantaneously change the state of other one in predictable way. So this will happen even if they are separated by very long distances. So here you can see the entanglement. So now we will discuss decoherence. The interaction of qubits with other environment in a way that cause their quantum behavior to decay and ultimately disappear is called decoherence. So here you can see the process of decoherence or decaying. So here you can see in the figure that this qubit is decaying. So this is called decoherence. The quantum state is extremely fragile. The slightest vibration or change in temperature, disturbance known as noise in quantum speak can cause them to tumble out of superposition before their job has been completely done. That's why researchers do their best to protect qubits from outside world in those super cooled fridges and vacuum chambers. So, what is quantum supremacy? It is the point at which quantum computers can complete a mathematical calculation that is not possible by the other computers, even the most powerful supercomputers. But it is still unclear how many qubits will be needed to achieve this, because researchers keep finding new algorithms to boost the performance of classical machines, and supercomputing hardware keeps getting better. So where these quantum computers will be used? So one of the most important application of these quantum computers will be in simulation of behavior of matter down to the molecular level. So still many auto manufacturers like Volkswagen are using quantum computers to simulate the chemical composition of electrical vehicle batteries to help find the new ways to improve their performance. And the other possible field for using this quantum computing is the pharmaceutical companies. So, of pharmaceutical companies, they can analyze and compare compounds that could lead to the creation of new drugs. So these machines are also great for optimizing problems because they can crunch through vast numbers of potential situations extremely fast. So even Airbus is using these quantum computers nowadays. It could take quite a few years for quantum computers to achieve their full potentials. So many universities and many multinational companies are working on the quantum computing, and they are trying to develop a quantum computer. So today we discussed quantum computing and the quantum computers, and how does a quantum computer work. So this was all for today. So if you have any question, please feel free to contact me. Thank you very much for today. See you next time.